Welcome back. Over the last few episodes, we established that our AI agent is basically a stateless brain in a jar. Every single time it takes a lap, reading a file, running a command, or writing code, the harness has to send it the entire history of the conversation all over again.
Right, because the LLM has no memory of its own. The harness, that software body surrounding the brain, is responsible for keeping the transcript and handing it over on every single turn. But if you're working on a tough bug for 2 hours, that transcript gets massively long.
And that brings us to a major roadblock. The conversation simply cannot grow forever. Every model has a hard limit on how much text it can process at once, which is called the context window. If you think of the context window as a desk, eventually you run out of surface area to put new papers on.
Exactly. As of 2026, those desks have gotten incredibly large. Some models can read a whole book in one go, but a sprawling, multi-hour coding session with thousands of lines of terminal output and file reads will still fill it up. And even before you hit that hard limit, you run into the sheer friction of carrying all that baggage around.
So, the harness has to step in. It has to act like a very ruthless editor. It realizes that sending the verbatim history of 50 laps is no longer feasible, so it decides to clean house. It kicks off a process that developers call context compaction. Let's talk about why that is so essential.
Quick, honest note before we dive in. This is an education series, not advice of any kind. We are just two curious people trying to make AI make sense.
And AI moves fast, so everything here is how things work as of 2026, and it will keep changing. Treat it as a map, not gospel. The real learning happens when you go and try it yourself.
Let's look at the actual cost of a long session. When you're on your 50th lap, the harness is resending the first 49 laps every single time it asks the model what to do next. It is like rereading the entire history of the Roman Empire just to decide what to have for breakfast.
Laughs. That is a great way to put it. And remember, in the AI world, you pay per token. Tokens are like syllables or fragments of words. If the harness is sending 50,000 tokens on every single lap, and you are doing dozens of laps, the bill racks up incredibly fast. You are paying to transmit the exact same historical data over and over again.
But it is not just about the money. There is also a performance tax. When you stuff the context window with massive amounts of old, resolved information, the model can actually get distracted. It is a known phenomenon. The more noise you pack into a prompt, the harder it is for the LLM to focus on the immediate pressing task.
I have definitely seen that happen. The model might hallucinate and try to fix a bug that was already solved 30 laps ago, simply because the old error message is still sitting there in the transcript. So, dragging a massive historical transcript around is slow, it is expensive, and it degrades the quality of the model's reasoning.
Which means the harness cannot just passively append things to the bottom of the document. It has to actively manage the memory space to keep the agent sharp, focused, and financially viable for the user. It has to compact the context.
So, what exactly is context compaction? When the harness detects that the conversation is getting too long, maybe it hits a specific token threshold, it pauses the main task. It takes all those old conversational turns, the back and forth, the failed terminal commands, and it asks the LLM to write a summary.
Yes, the harness says, hey, read these past 50 laps and give me a highly condensed version of what happened. What was the goal? What did we try? What worked? It takes that massive transcript and replaces it with a concise set of bullet points. It swaps out the raw data for a synthesized summary.
And this is a crucial point. Compaction is lossy. You are permanently throwing away the verbatim word-for-word history. The exact error trace you got on lap 12? Gone. The slightly meandering path you took to understand the file structure? Gone. It is replaced by a simple sentence saying, explored file structure and found the database schema.
Which sounds terrifying if you're a developer used to keeping everything in your terminal buffer. We are so used to scrolling up to see exactly what happened 3 hours ago. But in an agent workflow, you have to let the harness throw that raw data away.
Right, because the summary is much, much smaller. A 50,000 token history might get compressed down to just 1 or 2,000 tokens. The next time the harness sends a prompt to the LLM, the payload is lightweight. The model can process it faster, it costs significantly less, and the agent's attention is squarely on the present.
But that raises the obvious question. If compaction is lossy, and we are throwing away the actual history, how does the agent stay on the road? How does it remember what it is supposed to be doing if the transcript has been shredded and replaced with a summary?
That is where the design of the summary becomes so critical. A good harness doesn't just ask for a generic recap. It uses a purpose-built system prompt for the compaction task. It explicitly tells the model to keep the overarching goals, the key technical decisions, the open threads that still need work, and the immediate next steps.
Exactly. The compaction is highly structured. The model might discard the exact text of a compiler warning from lap 20, but the summary will explicitly state, decided to ignore type warnings in the legacy module. It retains the decisions, not the raw input that led to them.
Also, the harness doesn't usually compact the entire history. It almost always keeps the most recent turns, say the last 5 or 10 laps, word for word. That way, the agent has a high-resolution view of the immediate past and a low-resolution, summarized view of the distant past.
I like to picture it as looking in a rearview mirror. The car right behind you is sharp and perfectly clear, which represents the most recent turns. The cars way back on the horizon are just blurry shapes. You know they're there. You know generally what they're doing, but you can't read their license plates. That is the compacted summary.
Laughs. That is a perfect analogy. The combination of a structured, decision-focused summary and a high-resolution window of recent events gives the LLM exactly enough context to keep driving forward without swerving off the road.
But even with a great summary, relying solely on the conversation transcript is risky. The biggest safeguard, the real reason agents can survive having their conversational history wiped, is that durable state lives outside the transcript.
This is so important to understand. The transcript is just the temporary chatter between the brain and the harness. The actual, permanent reality lives on your hard drive. The files on disk, the actual code base, the persistent memories. Those ride alongside the session, completely untouched by the compaction process.
Exactly. If the agent spent 40 laps rewriting a complex Python script and then the context is compacted, it doesn't matter that the LLM forgot the exact steps it took to write the script. The script is saved on the disk. The harness can just use tools to read the file again if it needs to know what is in it.
The summary just has to act as a pointer. It just needs to say, we updated auth.py to use JSON web tokens. The agent doesn't need the code in its memory. It just needs to know that it happened, so it can go look at the file if necessary. The file system is the ultimate, uncompactable source of truth.
And many modern harnesses go a step further. They have a persistent memory system. They might store key facts in a local database or a hidden file that gets injected into every single prompt, completely bypassing the compaction logic. So, the state of your project isn't just surviving. It is actively anchored outside the ephemeral conversation.
When you realize that the agent is just manipulating state on a disk, you stop worrying about the transcript. The conversation is just the scaffolding. Once the code is written and saved, the scaffolding can be torn down and rebuilt smaller. The building itself, the code base, is perfectly safe.
This brings us to a really practical habit for developers who are collaborating with these agents. Because you know the transcript is going to be compacted eventually, you should never leave important information hanging in the chat window. You need to write it to disk.
Yes. If you and the agent spend an hour brainstorming an architecture plan and the agent outputs a brilliant, detailed markdown file in the chat, do not just leave it there. Ask the agent to save that output to a file, like architecture_plan.md in your project folder.
Because if you leave it in the chat, it is just conversational history. And when compaction hits, that brilliant 500-word architecture plan might get reduced to a bullet point that says, brainstormed architecture. The brilliant details will be lost to the void.
But if you tell the agent to write it to a file, you are moving that knowledge from the fragile, temporary transcript into the durable, permanent file system. Once it is on disk, it is safe. Even after the conversation is compacted, the agent can always just use its read tool to pull the exact plan back up.
It is a massive shift in how you use AI. With standard chatbots, the chat thread is the document. With AI coding agents, the chat thread is just a temporary workspace. Your goal should always be to materialize your decisions into actual files. Write to disk first, and you will never fear a context compaction again.
A great way to visualize this whole process is to think about a really long, rambling corporate meeting. Imagine you're in a boardroom for 3 hours debating how to launch a new product. There are side conversations, bad ideas that get rejected, and a lot of small talk.
If you tried to hand a transcript of that entire 3-hour meeting to someone who wasn't there and asked them to summarize the next steps, they would be overwhelmed. It is too much noise. They don't need to know exactly how Bob worded his objection to the marketing budget.
Right. So instead, you have someone take meeting minutes. The minutes drop all the small talk. They drop the verbatim quotes. They just keep the final decisions, the action items, and the assigned tasks. That is exactly what context compaction is doing to the agent's history.
And to tie it back to our previous point, if you reviewed a 50-page financial report during that meeting, you don't transcribe the 50-page report into the meeting minutes. The minutes just say, reviewed Q3 financial report, see attached. The actual report is the durable state on disk.
Smiling. Exactly. The meeting minutes just point to the real documents rather than retranscribing them. Context compaction works the exact same way. It turns a rambling, messy history into crisp meeting minutes and relies on the attachments, the files on disk, to hold the real weight of the work.
So, to recap, because every lap rescinds the entire history, long sessions get slow and expensive. The harness solves this with context compaction, replacing the verbatim transcript with a condensed AI-written summary.
It stays on the road by keeping a structured list of goals and decisions alongside a high-resolution window of the most recent turns. But the real safety net is that the true state of your project lives outside the chat, on your hard drive.
Next time, we're going to tackle a fascinating question. If the agent is just a brain and a harness, why do some brains work better than others? We're going to look at what actually makes an LLM good at this job and why a model that aces a coding benchmark might actually be a terrible agent. See you in the next episode. And that is a wrap for today. If this made AI feel a little clearer, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are learning and building with AI right alongside you, one episode at a time. So hit follow, and we will see you in the next one.